Okay, so hello everyone, once again welcome to BGP series. Guys, today in this video we will understand what is the best path selection criteria in BGP, right? Practically we will discuss practically. In last video I had discussed theoretically, right? I had discussed some attribute, 12 types of attribute. Let me remind the 12 types of attribute first. And so first attribute was next hop reachability, right? Okay, so here see 12 types of attribute. First attribute is next hop reachability, next hop reachability, right? Second one is wait. Third attribute is local preference, right? Fourth attribute is self advertisement. Fifth attribute was path means number of ES in the update, right? And sixth attribute was origin code. Seventh attribute was MED. Eighth attribute was external over internal, right? Ninth attribute was IGP cost. 10th attribute was oldest path. 11th was lowest neighbor router ID, and 12th attribute was lowest neighbor address. Lowest neighbor IP address. Okay, so guys, in this topology, this is my topology. Here I am going to configure BGP, right? Here I am going to configure BGP, right? In this domain, actually this is my private network. This is my enterprises network of PM networking. Suppose network of PM networking. Here I am using OSPF for connectivity between these router, right? Between these router I am configuring. I had already configured OSPF process ID 1 and area 0. I will configure BGP as number 10, and here on we have 3 link, right? We have 3 link that I had purchased from ISP. So one from Sprint US and 2 link from British Telecom BT. Okay, so here I am running IP 100.1.1.0/24. so here I am running actually 101.1.5, and here I am running 101.1.1. okay, here I am running this IP address, here I am running this IP address. Fine. Between R6 and BT router I am running 100.1.1.0/24 network. Between R5 and BT router I am running this network 101.1.1.0/24. and on this router in my enterprises network I am running one loopback on every router, right? Suppose on R1 I am running loopback 123.1.1.1. on R5 I am running 123.5.5.5 loopback, right? First of all guys, let me show you, and then I will configure BGP. So BGP AS number 100 over here and BGP AS 200 over here. So which type of neighborship will be for iBGP, right? Different AS. Okay, here also iBGP, here also what happened, iBGP, right? Here also iBGP, and here also iBGP, right? So when R5 will receive these prefix, right? Actually here I am running AS 5000 and on this router I am running AS 200. So here also we will form iBGP neighborship. Fine. So when I will advertise this prefix, these prefixes in BGP, right? This router will advertise this prefix with BT router, and BT router will advertise with Sprint US router and R6 as well as R5. Now R5 will receive this prefix from two sides, right? From BT router and US router, right? So when this router will receive this prefix from two sides, then we will discuss how this router will find best path to reach in this network, because BGP is not performing load balancing by default, right? BGP will install only one prefix in their routing table. So how R5 will find best path to reach in this network? Then I will configure BGP on this router and I will form iBGP neighborship with R5 as well as with R6. Okay, so my logical topology will be like this. Here is my R1, here is my R5, here is my R6. Okay, so like this, and here is US router and here is BT router, right? Here is BT router. So this is my logical topology, right? Then I will show you, first I will show you how R5 will calculate best path, then I will show you how R1 will calculate best path to reach in this network. Fine. So first of all, let me configure this topology, guys. Then I will discuss these 12 types of attribute as well. I will show you this 12 type of attribute practically in this video. Okay. So guys, first of all, go to R1 and let me show you IP interface brief. Okay. So IP interface brief, exclude unassigned. Now you can see there is one loopback. There is one loopback, right? And I am running OSPF as well. So IP protocol. So you can see I am running OSPF process ID 1. All interface are advertised in OSPF, right? So their connectivity with R5 and R6. So IP root OSPF. So you can see, right? There is connectivity with R5 as well as R6 as well as R4, R3, R2. Am I right? Now, am I able to ping 123.5.5.5 from here? So yes, there is connectivity in my enterprises network, right? Now I am going to configure BGP. So first of all, I am going to form neighborship between R5 and Sprint US router, right? iBGP neighborship, and R5 with British Telecom router, right? Now, so go to R5 and let me configure BGP first. So R5, let me show you. There is only one protocol running, so IP protocol, only OSPF, right? So now I am going to configure BGP over here. So command is simple, router BGP, S number is 10 for my enterprises network, right? And neighbor is 101.1.1 and whose remote AS is 100. Fine. After that, neighbor is 101.1.1.1. Remote AS is S number of British Telecom router is 200. Fine. Now let me configure R6. So here also I am using AS number 10. So router BGP AS number 10 and neighbor is 102.1.1.1 and remote AS is 200. Right? AS number of British Telecom, and here I am running network 102.1.1.0/24, right? So guys, now let me configure Sprint US router. So go to configure terminal mode, router BGP, AS number is 100 and neighbor is 100.1.1.5 and remote AS is here on this router R5. I am running network, I am running IP address 100.1.1.5, right? And remote AS is 10. Wait, never see bill. Yes, you can see the log message. Just wait. Yes, you can see. Adjacency is for between R5 and Sprint US router. And one more neighbor is 10.0.0.2. And remote AS is 200. British Telecom. So let me show you. So iBGP summary. You can see there is two neighbor, right? One neighbor is down now. Right? So now let me configure British Telecom router BGP on this router. So configure terminal, router BGP, and AS number is 200 and neighbor is 10.0.0.1 and remote AS is 100. Fine. After that, one more neighbor is 102.1.1.6 and remote AS is 10. Fine. Now guys, let me show you the BGP neighbor table. So iBGP summary. So see, both neighbor are up. Now let me configure R7, right? Router 7. Let me show you first of all IP configuration. So IP interface brief, exclude, unassigned. So I think there is unassigned. So yes, I had already configured loopback IP address, right? So now let me configure BGP, configure terminal, router, BGP, and AS number is 5000, right? And neighbor is 200.1.1.1 whose remote AS is 200. Fine. Now in the same way, let me configure this neighborship on British Telecom as well. So go to configure terminal, router, BGP 200 and neighbor is 200.1.1.2 and remote AS is 5000. Right now, neighborship will form. Just wait. So iBGP summary. You can see there is neighborship. Right now, I am going to advertise this prefix in BGP. So first of all, let me form neighborship between R1 and R5. Which type of neighborship? iBGP neighborship. And R1 to R6 as well. So after that, I will advertise this prefix in BGP. So go to router number 5 first. Router number 5 and one more neighbor is 123.1.1.1.1 whose remote AS is 10. Fine. Now go to R6 and say one more neighbor 123.1.1.1 whose remote AS is 10. Now let me configure R1. Go to configure terminal, router, BGP 10 and neighbor is 123.5.5.5 whose remote AS is 10 and one more neighbor is 123.6.6.6 and remote AS is 10. And whenever you will share any update to neighbor 123.5.5.5, update source loopback 1. And whenever you will share any prefix to neighbor 123.6.6.6, update source loopback 1. Right? In the same way, you have to configure this command on R5 and R6 as well. So neighbor is 123.1.1.1 and update source loopback 1. Go to R6 as well. So neighbor is 123.6.6.6 update source loopback 1. Right? Okay. Which type of error I am getting? Okay, 123.1.1.1, right? 1.1.1 update source loopback 1. Now you can see on R1 I had configure BGP, so there will be neighborship, so IP BGP summary. So see, there is two neighbor, right? There are two neighbor. One is 123.5.5.5 and second one is 123.6.6.6. So guys, if you have not watched my theory video path attribute, then first you should watch that video, right? Then only you will understand this video, right? So if you are not watching in series, right, if you want to learn each and everything, then you need to watch all video in series, start from day one, right? Then you will understand each and everything. Now I am going to advertise this loopback which I am running on this router R7 in BGP, right? So when I will advertise this prefix in BGP, right, in BGP, this router will share this prefix with British Telecom router, and British Telecom router will share this prefix with Sprint US R5 as well as with R6, right? So go to router number 7, and first of all let me advertise this prefix. So router BGP is number 5000 and network is not neighbor, network is 192.168.10.0. second network is 192.168.101.0. third network is 102.0. third network is 103.0. right? Now guys, let me show you the BGP table. So IP BGP, you can see there is prefix, there are some prefix, right? Now let me show you on British Telecom router first, BT router. So you can see, so IP BGP, so there are some prefixes, right? These all prefix. Okay, now let me show you on Sprint US router as well. So IP BGP, so there are prefix, yes. So guys, first of all, why Sprint US is receiving this prefix via British Telecom only, right? Why this router is not advertising this prefix with Sprint US? Right? Because this router have to advertise this prefix with Sprint US as well, right? So if you know, then please write your answer in comment why this router is not advertising this prefix with Sprint US router, right? So now guys, first of all, let me show you the BGP table of R5. So R5, go to R5 and so IP BGP summary, not summary, so IP BGP, you can see. So this router is receiving this prefix via 100.Sprint US only. So let me check. So IP BGP summary. So okay, so this neighbor is down 101 dot. Okay, this neighbor is down. So BGP, so running configuration section router BGP. Let me do troubleshoot. So neighbor is 101.11 and remote access 200. Now let me check on British Telecom. So running configuration section router BGP. So neighbor is 101, no, neighbor is 10. Okay, so I had run this command, right? By mistake I put 10 over here, so we need to correct it. So go to router BGP, yes, number is 200, and first of all remove this command. No. Right? After that, neighbor is 101.1.1.5 and remote AS is 10. Right? Now guys, let me show you on R5. Yes. So IP BGP. So just wait. So IP BGP summary clear IP BGP are soft in, and so BGP summary. So BGP again, this router is receiving this prefix via US only. Just wait. Let me check on R6. So IP BGP. So IP BGP. So this router is receiving this prefix via 102.1 British Telecom, but British Telecom is not advertising this prefix with R5, right? Why? So go to British Telecom and let me check. So IP BGP summary. So there is one neighbor 100.1.1.5, 5 remote AS is 10, right? 101.5 and 102.5. Fine. And let me configure one more neighbor, 10.1. So router BGP 200, neighbor is 10.0.0.1 and remote AS is 100. So IP BGP. Okay, now guys, let me check on R5. See, now it's fine. Now R5 is receiving this prefix via one via Sprint US router and one via British Telecom router, right? Now, but via British Telecom, this is a best. Via Sprint US, this is only a valid. This is only a valid route. Why? So first of all, what router 5 will check. And now guys, if I will show you the BGP table of Sprint US, so IP BGP, so you can see this router is also receiving this prefix via British Telecom as well and via R5 as well, So now it's fine. Now guys, let me show you R5 first. So IP BGP. So you can see there is two paths. One is via Sprint US, this is via Sprint US, this is via British Telecom. So first of all, they will check next hop reachability, first attribute. So both next hop is reachable, right? 101.1.1 is also reachable and 101.1.1 is also reachable. So ping 100.1.1.1, yes, reachable. Ping 101.1.1.1 is also reachable. So now tie. Now next hop reachability is tie, means both paths are best. Then they will check weight. So guys, these prefixes are this router receive this prefix by their neighbor. So weight will always 0 for received prefix, right? We have discussed in theory that weight for self-advertised router route is 32768, but for received route, right, weight will be 0. So if you will see the weight on R7, so IP BGP, then weight will be 32768, right? 32768. But if you will check weight on R5, so weight will be 0 from both sides, right? So weight is 0 because both are received prefix. So again, weight is tie. Now both path is best path. Then they will check local preference. Local preference will be 0 for BGP, for eBGP, right? And 100 for iBGP. We had discussed in theory. So this router R5 received this prefix from eBGP, so local preference is 0. You can see local preference is 0. So again local preference is tie, then they will check self-advertised. So both routes are received by router, right? This router is not advertising this prefix, so they will not check self-advertised, right? So self-advertised is also tied, then they will check AS path, means total number of AS. So if when this router R5 is receiving this prefix via a Sprint US router, you can see how many AS number are there, 3 AS number, right? 100, 200 and 500. But when this router is receiving this prefix via British Telecom router, there is only 2 AS, 200 and 500, right? So now lowest number of AS will always preferred. So that's the reason why this path is best, because via British Telecom there is only 2 AS. Number of AS, right? Number of autonomous system number. Fine. So that's the reason why this path is best path via British Telecom. Because via British Telecom R5 is receiving only 2 AS. Right, to only 2 number of AS, but via a Sprint US router, this router is receiving total number of 3 AS, right? So that's the reason this path is best. In the same way, if I will show you the BGP table of R6. So R6 is receiving this prefix via British Telecom only, right? Only via British Telecom. Yes, definitely, because there is only one neighborship with R6. Right? There is no neighborship with Sprint US to R6, right? So this router is receiving these prefix via British Telecom router only. So definitely these all paths are best path. Now guys, first of all let me show you the logical. First of all let me draw logical topology. So here is my R1, here is R5, and here is R6. Here is US router and here is BT router, right? Here is BT router. This is my logical topology. So when R6 will also advertise their best routes with R1, and R5 will also advertise their best route with R1. So when R1 will receive this prefix via two sides, then how R1 will calculate best path? Let me show you the BGP table of R1 first. So go to R1 and let me run same command, show IP BGP. So here you can see R1 is receiving, okay, so all paths are only valid, right? Not best. Why? What is the reason? If you know the reason, please write your answer in comment section, right? And reason is, guys, very simple, because the next hop reachability, right? This router is not reachable with 101.1.1.1. So what command we need to run on R5 and R6? What command we need to run on R5 and R6? Simple. Router BGP and neighbor is 123.1.1.1 and next hop self, right? Actually, whenever router will share prefix with their iBGP neighbor, they will not modify next hop address. So that's why I am running this command. After running this command, this router will modify next hop address, right? They will add next hop as a self. Fine. So we need to run same command on R6 as well. So go to configure terminal on R6, configure terminal, router BGP 10 and neighbor is 123.1.1.1 and next hop self, right? Now if I will show you the BGP table of R1, see, okay, let me clear the BGP process. Oh, clear IP BGP star soft in. Okay, now you can see, right? So this from R1, right, via R5 is not a best path. This is only a valid path, but via R6, this is a best path as well as valid path. So why? So again guys, R1 will check first next hop reachability. So next hop is 123.5.5.5 and second next hop is 123.6.6.6. So both next hop are reachable. You can see ping 123.5.5.5 reachable, right? Ping 123.6.6.6 reachable. So they both paths are best. Now they will check weight. So what will be the weight? Weight for internal iBGP prefix is 100, right? So iBGP. So you can see weight is 0, right? Weight will be always 0 for received prefix, right? So this is received prefix, so weight is 0. Fine. Now they will check what? Local preference. So local preference for iBGP route is 100, right? So again local preference is tie. So next hop is tie. After that weight is tie, local preference is tie. Then they will check self-advertised to so both routes are received by their neighbor. So again self-advertised is tie. Then they will check AS path, means number of AS. So in both update there is two AS number, right? So again AS path is tied. Then they will check origin code. So origin code, this is BGP route, so origin code will be I from both side, right? So origin code is also tied. Then they will check MAID. So MAID will also tie, because we had discussed in theory that MAID is a metric when you will redistribute any other routing protocols routes in BGP. Then the metric of iBGP protocol is considered as MAD in BGP, right? So MAD is also tied. Then they will check external over internal. So both prefix is received by internal router. So again this attribute is tied. Then they will check iBGP cost to reach next hop address. So guys, iBGP cost to reach next hop address, if I will open this prefix in detail, so IP BGP 192.168.100.0, you can see guys here. Let me show you something first. Wait. Okay, so this is a path. This is a path via R5, and this is a path via R6. So you can see here this one is next hop address. This one is next hop address. Let me change the color of pin. This is next hop address, right? This one is from where this router is receiving this prefix. So this one is neighbor IP, and this one is neighbor router ID, router ID of their neighbor. Fine. So what is the cost? Internal cost for this prefix is 67. And what is the cost, internal cost, when this router is receiving this prefix via R6 is 66. So which cost is lower? This one, right? So via R6, R5 is receiving this prefix with lowest internal cost. So that's the reason via R6 this path is best path via R6. So IP BGP, you can see via R6 is the best path. Via R5, this is only a valid path, not best path. So this router will install this path in their routing table. So why this router calculate this path as a best path, select this path as a best path? Because of IGP cost to reach next hop, right? Okay, so what will happen if I will, let me show you tell me what will happen. So understand, on this router on R1, this router is calculating cost 1 over here, 1 over here, and for serial link cost is 64. So 64. So total cost to reach to this IP is 65, 64, 65, 66, and cost for loopback is 1. So 67. But if I talk about this loopback, so cost to reach on this loopback is 1, 64, and 1. So 66. So what will happen if I will increase the cost of this link? If I will increase cost of this link, right? Now this router will receive this prefix with equal cost, equal IGP cost, right? So first of all, let me increase the cost of this interface, guys. This interface cost, right? Or I can increase the cost of loopback interface of R6 as well, right? So I am going to increase the cost of this interface, right? Cost of this interface on R4 serial 2/1. So first of all, if I will show you the IGP cost on this router, so you can see 100.0. So cost via R6 is 67 and cost via R5 is 65, or you can verify it in OSPF as well. So IP root OSPF. So you can see to reach this loopback cost is 67, to reach to this loopback cost is 66. So now guys, go to R4 and let me increase the cost of serial 2/1. So interface serial 2/1 IP OSPF cost is 65. Okay, now go to R1. Now you can see, wait guys, wait for some time. So you see now cost is equal from both sides. So now if I will show you BGP table, so BGP, so IP BGP. Now you can see best path is via router 5. Now best path is via router 5. If I will open this network in detail, so IP BGP 192.168.100.0. so you can see now cost is equal, internal cost is equal. So what this router will check now? This router will check oldest path, but oldest path is checked only for eBGP. So here this router is receiving this prefix from iBGP, so this router will not use oldest path. So now this router will check lowest neighbor router ID. So lowest neighbor router ID via R5 is 123.5.5.5 and via R6 is 123.6.6.6. So this router is receiving this prefix with lowest neighbor router ID, right? So that's the reason now this path is best path. But what will happen if I will decrease the router ID of R6? Let me configure different router ID on R6. So router BGP and AS number is 10 and router ID, sorry, BGP router ID is suppose 6.6.6.6. So now let me show you on R1. So BGP table. So IP BGP. So just wait guys, wait for some time. Clear IP BGP start soft in. Wait. Okay, so this router is receiving via R5 only now. So IP BGP summary. Oh, So clear iBGP star soft in. What happened? BGP. So this router is not advertising this prefix because 100 1.102.1.1.1 is now this router is receiving this prefix, but this is only a valid prefix, not best prefix. Why? This next hop is reachable. Yes. So iBGP. Now these are best, right? Now if I will show you on R1, you can see which one is best path via router 6, because this time router ID of R6 is 6.6.6. If I will open this prefix in detail, so iBGP 192.168.100.0, right? So you can see the router ID of this via R6 is 6.6.6.6 and via R5 is 123.5.5.5. Now this one is lower router ID, lower neighbor router ID. So again, that's the reason why this path is best path. So iBGP. So you can see via R6 is best path. What will happen if I will set same router ID on R6? Let me on R5, sorry, on R5 router BGP and router, sorry, BGP router ID is 6.6.6.6. Wait. So iBGP, just wait for some time. BGP convergence time is more, right? Now then they will check lower neighbor IP address, right? Now R1 will check lower neighbor IP. Clear iBGP star soft in. Just wait. La, 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 la. No. आजा भाई. See, now go to R1. So iBGP. Again you can see via R5 is the best path, because this time, so iBGP 192.168.10. Sorry, not 10, 100.0, right? Now this time router ID is in same, right? Now they will check lowest neighbor IP address. So lowest neighbor IP address is this one, right? So this one is lowest, right? So this one is lowest. So that's the reason this path is best path. So guys, this is 12 types of attribute that we had discussed in theory. So this is practically how router is calculating best path in BGP, right? Best path in BGP. So that's all for today. If you like this video, please hit on like button. We have some more attribute, right? We will discuss in the upcoming time that type of attribute as well, like cluster list. So don't worry, we will discuss that type of attribute as well. If I will discuss all things in single video, then video length will very long, it will be very difficult for you to watch, right? So that's why I am going to end this video now. In next video we will discuss path manipulation. Okay, so bye bye guys, that's all for today. Thanks for watching.